How's it going, guys? Welcome to the last video on section 2.2 dealing with the definition of limits. In this last video, I wanted to go over additional examples involving limits and take the opportunity to show you how to use a calculator to more easily do limit calculations numerically. Alright, so let's go ahead and take a look. Now, before we begin, I want to remind you that if you're doing limit evaluations numerically, you gotta make sure that you try multiple evaluations here. Now, this is going to be especially important in one of these examples, as we'll see in a second. Alright, so let's go ahead and begin here with example 6, where we want to guess the value of the limit as x approaches 0 for sin of x over x, both numerically and graphically. Alright, so let's go to our graphing calculator and see if we can estimate our limit graphically, just to get an idea of, okay, what is probably the limit. Alright, so I'm going to go here to the graphing calculator, and let's go ahead and graph the sin of x over x. Alright, so now let's see how the graph looks like. So when we click on graph, well, it kind of seems like the limit is going to be 1. Now, I would agree that, yeah, it kind of looks like a 1, but I'm going to go ahead and change the window settings to maybe get a better picture here. Now, typically when you're graphing trig functions, the calculator itself has a nice feature here. When you click on window, when you click on zoom, you click on Z trig, and that's automatically going to readjust the window to give us a better sense of what's happening. Alright, so we get to see here the curve for the sin of x over x, and yes, it does seem to indicate that as the axis gets closer and closer to 0, the function, the sin of x over x, gets closer and closer to 1. Okay, well, let's go ahead and verify that with a table. Now remember, to obtain a table of values, all you need to do here is click on second and graph. And there we go, we're getting a table here. Now notice that when x is 0, we're getting an error. That makes sense because we can now divide by 0. Now take a look at the values here. I'm going to go ahead and scroll up here so we can see some of the negatives to see what's happening when you're taking a limit as you're approaching 0, coming in from the left and coming in from the right. Alright, so taking a look at the values, when x is -1, I get a 0.8415, and when x is 1, I get a 0.8415, and then I get an error. Now, based on the graph that we saw before, yeah, it kind of seems like the limit is going to be approaching 1. So, what I want to show you guys now is how we can tweak the table to get different values on the inputs. So, what I'm going to do here is I'm going to click on second and window to reach the table set option. Now, notice here that the table start here is marking at -5. That's where the table is starting. That's the first value that it picks. It's a -5. It's highlighted. Alright, so now I'm going to go here back to second window to go to the table set, and I'm going to tell it to start, let's say, at a 0.5. Well, you know what? I'm going to say it to start at a -1. Now, what I'm going to do now here is change the delta table here. Now, the table here is now indicating a 1, and that's basically telling you that, okay, you're going to pick a -1, and then you're going to go in intervals of 1. That's how we go from the -1 to 0, then to 1 to 2. So what I'm going to do here is the delta table here, the intervals, I'm going to make them much smaller. I'm going to go for, let's say, 0.01. So now what's going to happen here is the table is going to start here at -1, and then it's going to change by intervals of 0.01. So let's see, second and table. There we go. Now I get a -1. All right, so now you get to see here that, okay, maybe I selected a very small interval. That's okay, I'm just going to go here to second, table set, I'm going to tell it to start, well, you know what, I'm going to change it at, there we go, 0.1. And I'm going to tell it to start at a -0.5. Alright, so now let's see what happens. So second table, there we go, I'm starting at the -0.5, -0.4, keep coming down. Okay, I'm still getting an error at 0, as expected. But notice here that the values that your function is approaching as the x gets closer and closer to 0, coming in again from the left and from the right, yes, it does seem to indicate a 1. Alright, so now we've just shown both numerically and graphically, then yes, the limit for the sin of x over x as x approaches 0 will indeed be 1. Now these two techniques, they're fine, but later on in class, I'm going to show you how we can prove this limit actually algebraically. Alrighty, now I'm just going to go ahead and copy and paste the table here so it's on the notes, and I'm going to go ahead and copy and paste the graph as well. There we go. Here's a function, the sin of x over x, And as we saw right now, the limit for sine of x over x as x approaches 0 is indeed 1. Alright, now let's go ahead and take a look at another example here with the sine function. This time around, we're trying to see if we can get the limit as x approaches 0 for the sine of 1 over x. And again, we're going to do it both numerically and graphically. Alright, now just as we did before, let's go to our graphing calculator and see if we could maybe take a guess as to what is the limit for the sine of 1 over x as x approaches 0. Alright, so going to y equals 2, now we have the sine of 1 over x, and again notice that we cannot let x equal to 0 because again we cannot divide by 0. Alright, so I'm going to go ahead and click on graph. Now the graph here, since I did not change the zoom options, is still in the trig option. Alrighty, now this graph though is not as smooth as the other one. Seems like something funky here is going on near x equal to 0. Okay, since the graph is not providing a lot of useful information, I'm going to go to the table instead. But here's a trick that I want to show you guys. In the previous example, when we clicked on second and window to get to the table set, we got the table here to start at a negative 0.5 and go in intervals of 0.1. So let's see what happens here. If I click now on the table to see what we're getting, it's like, okay, well, what is happening near 0? All right, so when we're approaching from the left with a negative 0.1, we get a y value of 0.54. But when we're approaching 0 from the right with a 0.1, we get a negative 0.544. Okay, well, one of them is a positive, one of them is a negative. Now, this one here is a little bit of a problem. And when I say a little bit, well, maybe it's a big problem. Because remember, when you're getting the limit, you must approach a single value. You cannot approach a positive and a negative at the same time. That doesn't work. Okay, so what can we do? Maybe should we select maybe smaller intervals? We could, but here's a trick that I want to show you. Let's go back to second and table set. Now notice here that there's other options, the independent and dependent. Now the independent is set to auto. What that means here is that the calculator is automatically selecting x values according to the starting point and the step size that we wanted. But if you click on ask, this gives us here a lot more freedom to select certain x values. What I mean by that here is that now we actually get to tell the calculator, hey, do the evaluations at the x values of our choosing. So now that I've set this one here to ask, I'm going to go second and table. Now notice the table is clear here. Now I'm going to tell the calculator, you know what? Since I'm getting closer and closer to 0, let's go ahead and try a negative 0.01. That's a value that we tried, I believe. Now let's go for a negative, let's say a 0.001. Okay, now it's a negative 0.827. I don't like this. It doesn't seem to be approaching any particular value. Now let's see, maybe a negative 0.0001. This is going to be a small number, but okay, now it's the 0.3. So notice here we went from a positive to a negative to a positive with really small values for x. This does not bode well. I don't think I'm approaching any particular value. Let's see if I'm just put the 0 here as a distinction. Okay, there's the error. But now let's say that I put in a positive 0.0001. Okay, now it's another negative. So what's happening here? Well, I'm going to go back to the graph here. All right, now something funky was going on here, but let's see if we can zoom in near 0 to see what's going on here. All right, so I'm at x0, y0, and I'm going to go ahead and zoom in. Okay, now notice here that now it's just kind of looking like a bunch of scribbles. So what's happening here is that, well, it seems like the graph just kind of keeps on oscillating and oscillating without ever really reaching a number. If we zoom in again, let's see what happens. So zoom in. Okay, no, so you see here, what basically is happening here is just oscillating and oscillating and oscillating without really stopping. And that's what the table was telling us. You were going from positive to negative, so you're never really reaching a value. So a problem like this is a problem where the limit does not exist because you don't reach a single y value. So this problem here was kind of tricky. And this one here, to be honest, We can do it algebraically again just to show that the limit does not exist, but this is a nice example so we can see that yes, even though we're checking the limits numerically and graphically, sometimes the answer is, well, none. The limit sometimes does not exist. And that's what we have here. The limit for sine of 1 over x as x approaches 0 does not exist. Now I'm going to go ahead and attach a picture of the graph and the table so we can have it in our notes. But there we go. The final answer is does not exist. And there we go. This is it for our video lectures on section 2.2, definition of limits. I'll see you guys in the next recording. Have a good one.